In this video, we are going to work on converting our angles between radians and degrees. Now that we know that both exist, we need to be able to get from one to the other. The reason being is most calculus, you will be working with radians. And then as you're getting through your STEM degree, if you are a STEM major, engineering, physics uses a lot of degrees, so we need to be able to go back and forth. Okay, so just to talk about our notation, and then I'll show you there's a formula here that you can use. I like to use something called dimensional analysis, which is just a part of this. So we'll get to that. Theta by itself is the measure in degrees, and then we're going to use theta base r, or however you want to say that, theta sub r. That's going to be our radian measure. So the way we're going to set this up is it's just a proportion. Meaning like these are the things that we focus on a lot in algebra, is that this relationship is proportional, meaning that like as my degrees change, there's a direct relationship between my degrees changing and my radians changing. Meaning I can do this. So if we take a look at these relationships, this is theta, which is in degrees, over 180, is the same thing as theta sub r, which is our radian measure, over pi. And the reason we know this exists is because of equality here. 180 degrees is the same thing as pi. Now, we could set this up and multiply, and you guys, I hope you remember how to do proportions. Let me remind you, we do the cross multiplication thing. But let me show you a different way. And we're going to write how to get from one to the other. Well, if I take the equation here and I multiply both sides by 180, I get this formula. Theta is equal to, and I'm going to put 180 over pi. I'll put those together and then times by theta base r, sub r. So this is my formula right here. If I have the angles in radians, then I can get to my degree by multiplying by pi over 180. I can use the same logic in my formula down here to get the other one. I can multiply both sides by pi and get rid of that on the right, and that's going to leave theta sub r is pi over 180 times theta. So notice that to get from one measure to the other, we're multiplying by either 180 over pi or pi over 180. You got to remember those two. And the thing is about that, why that's easy to remember, is pi and 180 are the same thing. Okay, so this is how I like to think about it. So let's do number one here. And we're going to convert, it says radian measure to degrees. Okay, so I have pi over 6, and I like to write radians here just for this so you can see why I prefer this method rather than memorizing what's above on the screen. I know I'm going to multiply by some fraction of 180 and pi because they are the same thing, but I would like to end up with degrees. So I'm going to put radians on the bottom and degrees on the top. So this is going to be 180 degrees over pi radians. It tells me which one to use, 180 over pi or pi over 180. And the way it tells me is now I know that these radians are going to cancel out, and it's going to leave me with pi over 6 times 180 over pi degrees. That really helps. These pi's cancel, and I get a 180 degrees divided by 6, which I believe is a 30 degree. Right, so that's how we go from one to the other. I like this better. I know 180 and pi is what I'm going to use. I could even use 360 over 2 pi, anything that gives me an equality between degrees and radians. This helps me know if I flip it one way or the other because I need the units that we're in to cancel. Okay, so number two, even though it may not feel like it's radians, they told us it was. Remember, the only time it's going to be degrees is if they tell us degree like that or put the degree symbol. So this is 3. And then I know it's 180 over pi. The pi is going to go on the bottom because I want the radians to cancel. I guess I could write rad here. The radians cancel, and I'm left with degrees. All right, this becomes 3 times 180 is a 540 over pi degrees. And we just leave it like that. Right? It's okay to have that 540 over pi. We could multiply it out, divide it out. That would be based on our homework on what they're wanting. For a test, I'll be clear. I'll tell you if I want it exact or a decimal. Okay, number 3. We have, I'm going to do it right here. Sorry for that. If you heard my computer, give me an email. Let me mute my computer. All right, I got negative 3 pi over 4. And I'm going to multiply by, okay, this is in radians, so I'm going to put the radians on bottom. I'm going to put 180 degrees on top. The pi's cancel. 180 over 4 is 90 divided by 2 is 45 times 3 is 135, and I keep the negative degrees. The pi's canceled out. You could do all that in your calculator if you would like. It will still work. My mind just tries to do the arithmetic in my head first. It's kind of how I work. All right, let's do degrees now. I have 15 degrees, and this is why we use the dimensional analysis and not the ratio at the top or the proportion at the top, is now I want degrees to cancel, so I'm going to put degrees on bottom and radians on top. The degrees are going to cancel out, and I get 15 over 180. So 15 over 180 pi, and the degrees are gone. Okay, so we're going to divide by 5. I got 3 over, and then that would have been 40 if it was 200 minus 4, so it's 36. It looks like it goes down even more. So this is 1 over 12 pi. I believe that's it. Let me do 180 divided by 5 real quick, because I'm now second guessing myself. 36, we're good. All right, so that is we don't have to put rad. You can. You're more than welcome to, but we don't have to. Okay. The next one, 126 degrees times pi over 180. The degrees are going to cancel. I knew to put the 180 on bottom, so they will cancel out. And I got 126 over 180. I know 180 is divisible by 4. Let's see if 126 is. It is not. So I'm going to divide both by 2. So I got 63 over 90 pi. Okay, I know both of those are divisible by 3. 63 divided by 3 is 21. 90 divided by 3 is 30. Divide all those by 3. I got 7 over 10 pi. And that is my measurement in radians. It's pretty nice. The hardest thing I think about this, it's not the work, it's just memorizing. Do I multiply by pi over 180 or 180 over pi? But if you just pay attention to what the units are doing, the canceled unit needs to go on bottom. All right, one last one, negative 75 degrees. I multiply by pi over 180. The degrees are going to cancel. And then I'm going to divide, I think, by 5. 75 divided by 5 is 15. Stays negative. 180 divided by 5 is 36. Those are divisible by 3, so I got negative 5 over 12. And it's in radians, so I could put rad if I want for that. But most of the time for radians, we just leave it blank. So again, you could just plug up in here and solve if you're more formula-based and you can memorize that. My whole argument against memorization, oh, I forgot my pi here the whole time. I'm glad I caught that. Okay, the pi's there. My recommendation is that you memorize not the formula that I circled at the top, but that pi and 180 are the same thing, and we just really need to cancel units out. I think that is the best way, because in 8 months, when you're in your Calc 1 class or whatever, whenever you're going to take that, then hopefully you could remember to convert by using what's called dimensional analysis, that ratio of 180 over pi.